We'll try to understand the non-uniform flows. Okay, so flow, as I mentioned earlier, that flow could be uniform or flow could be non-uniform. So the presence of some abstractions in the channel, let's say gate, or the change of the slopes, the cross sections, it could change the flow types, and then flow can vary from uniform to non-uniform. So the this all of this reason what I mentioned earlier, like the gate, the change of the slope, the cross sections, it actually changed the flow depth, and the flow becomes non-uniform. There are some examples you can see, like the river flow, the irrigation system, the seal lines. So it could be, in most of the cases it is actually the non-uniform flow. So this non-uniform flow, it could be different types. Here we have the schematic, and this figure, it's actually clearly showing all types of flows. So the non-uniform flow, in other words, sometimes it's the varied flow. So this non-uniform flow, it can change rapidly or it can change gradually. So from uniform to non-uniform, it could happen very abrupt transition, like abrupt change, or it may change gradually. So you see here, this is a very small change of the slopes, like this. So for this case, the flow depth, it was quite uniform. So up to this, we can say this is uniform flow. This EF, that's the uniform flow. Now, due to this sudden, the change of the slope, you see here, it starts gradually changing the depth. So you see the change, the depth, it is decreasing. So we can say this is the gradually, varied, flow. Now, due to this sudden change, that's just the sudden change of the depth, you see, we can see a rapidly changed flow pattern here. It will not some sort of gradual change, but it is rapid change. So the flow depth changes significantly at these sections due to this, variations of the depth at this section. So we can say this is the rapidly depth flow. So once after this section, we can see now the slope, it's not changing a lot. You see the elevations from this point and this point, the difference is negligible. So now it stayed gradually forming the uniform flows up to the sections where the flow gradually changing. It is the gradually varied flow, and then now it's become again uniform. So this is uniform flow. So we'll analyze this. If the flow depth gradually changes, then gradually varied flow. If it rapidly changes, then rapidly varied flow. If it is uniform, then uniform flow. So I believe you understand. So now, how in pipe flow we can characterize the flow types like laminar or turbulent flow. How we can determine whether the flow is laminar or turbulent for open channel. So the same thing, we'll calculate the Reynolds number here, but the only difference is we need to know this hydraulic radius. In a state of the characteristics lines, here we will calculate the hydraulic radius, and here you will see the definitions for the hydraulic radius. It is the cross-sectional area over perimeter. So this is the hydraulic radius, and by using this we can easily get the Reynolds number. So we'll see some differences between the pipe flow, the internal flow, and this open channel flow. For internal flow, we know if the Reynolds number is less than 2300, then it is laminar. Okay, so now in open channel flow it's different. If it is less than or equal 500, then laminar. If it is greater than or equal 2500, that means this is turbulent. And in between these two values, this is transient. So transitional flow. So I believe you understand the difference between the internal flow and the open channel flow. And that's it for now.